Okay, let's look at this problem, which really deals with the dilation factor, that number that's multiplied in front of the absolute value function. So here we're obviously starting with our nice absolute value function, which is our v function. Starts at 0, 0, and kind of progresses on both sides like this. And so we want to know what happens when I do varying degrees of a coefficient in front. So the first one is very easy when it says if it's positive or negative. So if it generally is starting up, we say that a is positive. It only goes the other direction if it flips. So if we have a negative value for a, then this would flip. So in this problem, if I was going to say which ones are positive, which ones are negative, well, big A, which is that first graph, is opening up. So right away, I know the coefficient is positive. For the second one, it's also opening up, so it's going to be positive. For C and D, they are both opening down, so those are going to be negative. And that's true of anything. If it's a parabola and it normally opens up and it's flipped, then it's negative. Or if it's a square root that kind of goes off to one side, if it's flipped, then it is negative. Now, in this case, B, it says, find the coefficient with the smallest value. Okay? Well, as A gets bigger, the graph gets narrower. So if A increases, the graph should become narrower. And if it decreases, if A decreases, so if that number in front decreases, the graph kind of becomes wider. So if I'm looking for the smallest coefficient, the smallest value, I know it has to be either C or D. Now the reason I know that is that they are both negative and the other two are positive. So the one with the smallest value obviously has to be one of the negative values. So now I want to figure out which one is a bigger negative number. Well, we said if the value in front, if this number in front gets bigger, it becomes narrower. So if you look at which graph is narrower, I would say D is narrower than C. So D is going to have a bigger negative value than C does. So for example, if you just graph in your graphing calculator, if you graph, say, -2 absolute value of x and -1/2 absolute value of x, now the -2 is smaller because it's more negative. And if you graph this, you would see that this one is going to look something like this, while this one will be wider, something like this. So in this case, D is the smallest value because it's the largest negative. Now, when you're looking for the coefficient closest to 0, we don't worry about negative or positive. So we want it the closest to 0. The closest to 0 is going to be the widest graph. So we have to kind of see which graph looks the widest. So if I look at this, it's kind of a hard one to see, but I'm going to claim that is going to be A, because A is somewhat wider than C. It kind of comes down to A or C, but I kind of think A is a little wider, and the reason I do that rationale is if I go up one value in here, you can kind of see I had to go over 2, but over here I only have to go over 1 to get to that value. B and D are much narrower, so when you're looking for closest to 0, you're really looking for which one is the widest. So which one is the widest graph is always going to be the one that has a coefficient closest to 0. And again, this is something you could obviously graph and just play around with, pick some numbers, and that's obviously a good way to do problems that you might encounter like this.